In this video, we're going to continue examining how to rationalize the denominator of radical expressions. However, if we take a quick look at the two examples on the screen, we'll see these are different than the ones we worked with before. In the previous ones, we've only had a radical or a coefficient with the radical, a monomial. In these, we have a binomial. We see a plus sign, we see a minus sign, we see two separate terms. And so the process is going to be the same idea on how to rationalize, but you're going to use a different clever form of one. So you need to multiply to get rid of any roots with a binomial. You need to multiply by the conjugate, which we've learned before when dealing with imaginary numbers. Now the conjugate is going to be the same terms. So if I have a, let's say, plus the square root of b, the conjugate are the same terms, but the opposite operation. Now, the reason why this is you can go back to when you learned how to find the product of the sum and difference of binomials, a plus b times a minus b. If you were to distribute, you would get a squared plus ab minus b squared. These middle terms would cancel, and you're left with a squared minus b squared. The first term squared and the second term squared. Well, if I square root, the square root's gone. And what happens is by these middle terms canceling, all the roots are going to cancel. So the reason why it works goes back into the product of sum and difference of binomial. What we need to remember is how to find the conjugate of a radical expression, which just means take the same term on the left, same term on the right, and just change the operation. So if I'm going to look at example 1, 3 over 2 plus the square root of 5, well, I have to rationalize the denominator, so I'm going to multiply by my clever form of 1, which is going to be 2 minus the square root of 5 in the bottom, and the same thing in the top, 2 minus the square root of 5. Now, when actually doing the multiplying, you need to be careful. Always put parentheses around your binomial expressions, even the ones in the given original problem, because that tells us we have to distribute. So the top with distributing is easy. 3 times 2 is 6, and 3 times negative radical 5 is negative 3 radical 5. Now distributing the bottom is going to be a little more complicated at first, and then hopefully you'll notice the pattern for making it a little bit quicker to do. And the pattern comes from this whole idea of the sum and difference, the product of binomials, making a simple binomial expression. So I would do 2 times 2 as 4. 2 times negative radical 5 is negative 2 radical 5. 2 times positive radical 5 is positive 2 radical 5. Now radical 5 times negative radical 5 is negative. Well, the square root of 5 times square root of 5, well, the square roots are going to cancel. So I'm just left with negative 5. And what happens is the negative 2 radical 5 and positive 2 radical 5 cancel. You notice I no longer have a radical in the denominator. I rationalized it. And so in the bottom, what I'm left with is a 4 minus 5. And so what does that give me? That gives me 6 minus 3 square root of 5 in the top and a negative 1 at the bottom. Now this is the fun part. This is the tricky part for many students is remember this negative 1 goes to both terms. And we learned that back in chapter 6 when we divided by monomials. If you have an expression in the top separated by addition subtraction signs, the denominator gets split to both terms. So watch this. 6 divided by negative 1 is actually negative 6. Negative 3 divided by negative 1 is actually positive 3. So my final answer is actually negative 6 plus 3 square root of 5. Let's try this example. I have 4 minus radical 3 in the bottom. So I'm going to rationalize it by multiplying by 4 plus radical 3 in the top and 4 plus radical 3 in the bottom, my clever form of 1, just changing the operation. Anything that's a binomial gets parentheses put around it to assist me with distributing, and then I distribute. Distributing the top, easy, 5x and 4, 20x. 5x times radical 3, well, that's just 5x radical 3. Distributing the bottom. It involves a little thinking at first, and then we'll probably see a shortcut in the next example set. What you do is you take 4 times 4, and that gives me my 16. I take 4 times radical 3, and that's positive 4 radical 3. Negative radical 3 and 4 is negative 4 radical 3. And negative radical 3 and positive radical 3 is a negative 3 because the radicals just cancel. And you notice 4 radical 3 and negative 4 radical 3 cancel. I have rationalized the denominator. And I'm left with in the bottom just 16 minus 3. And so let's simplify. 20x plus 5x radical 3, we're just going to leave alone. And 16 minus 3 is 13. And so that is my final expression. Now, before I move on to the next example, the last example involving this, let's look at the shortcut. When we're rationalizing the denominator, the whole point is to get rid of our radicals. So you notice, when I distribute the 2 to the 2, I get a rational number, 4. But when I distribute the 2 to the negative radical 5, well, a radical is going to be irrational. If I distribute radical 5 to 2, I'm going to get an irrational. Radical 5 and radical 5, I mean, the radicals cancel, I'm left with a rational. So what's interesting is when I distribute a rational number to an irrational number, it's going to become irrational. But I know by rationalizing the denominator, they're going to cancel out. And if we look at our sum and difference here, a plus b times a minus b, notice what it simplifies into. Just the square of a. Well, a was 2. The square of a is 4. Just the square of b. Well, b was radical 5. Well, radical 5 squared is just 5. So a squared minus b squared. 4 minus 5. The square of 4 is 16. The square of radical 3 is just 3. A squared minus b squared, 16 minus 3 on the bottom, which is 13. So in this example, and if you don't see the shortcut, then just do the distributing and crossing out. But if you do see the shortcut, then practice the shortcut to build your skill. I'm going to multiply by a clever form of 1. So I'm going to use the same expression on the bottom, except for I'm going to change the operation. So it's square root of 2 minus 1 on the top and square root of 2 minus 1 on the bottom. And I'm going to put anything that is a binomial in parentheses to assist with distributing. And what do I get? Radical 2 times radical 2 is 2. Radical 2 times negative 1 is negative radical 2. Now let's just use our shortcut. Well, I know I have the sum and difference of a binomial, so what does that mean? That means that I'm going to square the first term. Radical 2 squared is 2. I'm going to square the last term. 1 squared is 1. And so I have a squared minus b squared. So I have 2 minus 1. And so that gives me 2 minus square root of 2 over 1, which is just 2 minus the square root of 2. So when you have a binomial with a radical in the denominator, you have to rationalize it by using the clever form of 1, which means be careful when distributing and your radicals should all cancel.